Let's take a look at the Kubernetes architecture. On the very high level, we have two main parts. The first one is the control plane, and also we have a worker node. So control plane is basically, it makes all the decisions, and the worker node do all the work. So how we can connect to the control plane? Usually we have in the Kubernetes, we have a UI where we can go and see the pods, we can see the node, how many nodes we have, or we can see the logs. And also we have a command line. So from the command line, we can send the command to spin up a container and so on. So for example, in this case, we are sending a request kubectl apply deployment YAML. So that request goes to the API server in the control plane. API server basically is the main entry point. All the commands that we are running, kubectl commands, they are going to the API server. So after API server receives that request, what API server does is it sends the request to the kubelet of the worker node. So each node, in this case, we have mentioned only one node, but in reality, we may have several nodes, right? So it sends that specifically to that worker node's kubelet request to spin up a container. So what kubelet does is it uses a Docker, it uses a container runtime, another part in the worker node to spin up a container. So also what we have in the worker node, right? So also in the worker node, we have a kubeproxy. What kubeproxy does is it handles all the networking rules inside and outside of the cluster. So how about this is all the parts that we have in the worker node, right? So we have a Docker, we have a kubelet, and we have a kubeproxy, and we may have one or several pods. And for each pod, we have one or many. In each pod, we can spin up one or several containers. So about the control plane? In the control plane, another part is the scheduler. When we are sending a request to the worker node, that is decided by the schedulers. Basically, let's say we are spinning up a new container, then in that case, what the server API does is it communicates with the scheduler, and the scheduler decides to which specific node send that request. And only after that, API server sends the request to the kubelet of that worker node. Another part in the control plane is the controller manager. So what controller manager does is it constantly checks if the cluster is in the desired state. So what's that mean? Let's say that we have three instances of our application running, and let's say that one of the instances has crashed. Then it's responsibility of the controller manager to detect that, and after detecting it, it sends the request to the API server to spin up a new instance. And another part is the etcd, is basically is the database for the Kubernetes. It's where the Kubernetes stores all the cluster states. So to sum up, let's revisit one more time, right? Let's see that one more time what exactly happens step by step when we are running kubectl command. Let's say that we are running again kubectl apply command. What happens first is that the API server receives the request, because this is the main entry point for us, right? And the next one is that the API server communicates with the scheduler to pick up a node. We may have hundreds of nodes, and it's a responsibility of the scheduler based on the workload to choose the node. After scheduler picks the node or nodes, then API server send the request to the kubelet of that node, the kubelet part of that node, and the kubelet then asks the Docker to start a container. Now the container has started, and what Docker does is Docker uses Linux kernel features to create an isolated container process. And also the operating system, it's like any other process, right? But it's with the isolation, networking, and the resources limits. The next part is that what is the collaboration between the Kubernetes and the operating system. Kubernetes itself doesn't manage hardware directly. Instead, it relies on the operating system for the followings. For the process management, Docker uses Linux kernel features like a namespace and the cgroup to isolate containers. Networking, the OS handles the IP stack and the routing between pods, and the file system and storage, volume, and mounts are created through the operating system. To sum up, the Kubernetes orchestrator above the Docker, and the Docker as an executor above the operating system kernel. And to our previous architecture, we can add two more parts. So to sum up what we have, right? We have UI, we have a command line, and we have two main nodes, right? Control plane and the worker node. So we may have, again, in one cluster, several nodes, and we may have several control planes, and how exactly they run in the worker node container. So in every worker node relies on the Docker to spin up a container, and what Docker does is it uses the Linux OS. It provides a kernel features such as networking, file system, and so on. And the operating system in itself is hosted on the top of the physical or virtual machine.